Hello everyone. Welcome back to this series. In the first two episodes, we completed the project setup and connected our app with the TMDB API. Now it's time to build something exciting. In this episode, we'll create the home screen. So let's get started. We'll use a box as the main container. Then we'll use a LazyColumn. This makes scrolling smooth, even when displaying hundreds of movies. Our home screen is divided into multiple sections. For now, we'll start with a single section, Trending Movies. Later, we'll add Popular, Top Rated, and many more. Each section will have its own horizontal movie list, just like the Netflix application. Later, adding a new category will be as simple as adding another item to this list. Inside the LazyColumn, we'll display each section using a reusable composable called MoviesSection. Instead of writing the SAM UI again and again, we'll reuse this composable for every movie category. Let's start by creating MoviesSection composable. It accepts three parameters. The first one is the section title. The second is a list of movies that we want to display. And the third is a click callback. Whenever the user taps on a movie, we'll receive its ID. We'll use this later to navigate to the movie details screen. Keeping navigation outside this composable makes it much more reusable. Inside the composable, we'll use a column. The column allows us to place the section title above the movie list. We'll also add some bottom padding so that each section has enough spacing from the next one. This small detail makes the UI feel much cleaner. Next, we'll display the section title using the text composable. We'll make it bold and increase the font size so it stands out. We'll also add some horizontal padding to align it nicely with the movie posters. After the title, we'll add a small spacer. This simply creates some vertical space between the title and the movie list. Now comes the most important part. We'll use a LazyRow. Just like LazyColumn, it only composes the visible items on the screen. We'll also add horizontal padding to the LazyRow. This prevents the first and last movie cards from touching the screen edges. Finally, we'll iterate through our movie list. For every movie, we'll display a MovieCard composable. Each movie card receives the movie object along with the click callback. Now let's build the MovieCard composable. This composable is responsible for displaying a single movie poster. Our MovieCard takes two parameters. First is the movie object. This contains all the information about a particular movie. Second parameter is onMovieClick. We'll wrap everything inside a card. We've given the card a fixed width of 120 dp. This size is very similar to what you'll find in popular streaming apps like Netflix. Inside the card, we'll use AsyncImage from the Coil library. Unlike a normal image composable, AsyncImage can download and display images directly from a URL. It also handles image caching automatically, which improves scrolling performance and reduces unnecessary network requests. The image fills the entire width of the card. We've also added a dark gray background. This acts as a placeholder while the image is loading. We've set the aspect ratio to 2:3. Most movie posters follow this portrait ratio. Finally, we've used content scale .crop. This tells Compose to fill the available space while maintaining the image's aspect ratio. Now we have a list of sections. So let's display each section inside our LazyColumn. One more important thing we need to handle is the movie poster URL. The TMDB API doesn't return the complete image URL. It only gives us the relative path of the poster. So we need to add the TMDB image base URL before the poster path. Now let's run the application and see what we've built so far. We have a trending section at the top, and each movie is displayed as a poster inside a horizontal scrolling list. Let's add a few more movie categories to our home screen. We also need to create the corresponding API endpoints. We already have the endpoint for trending movies. Now we'll add 3 more endpoints. All 4 endpoints return the SAM movie response model, so we can reuse the existing response model without creating anything new. Now we will update the repository to call these new endpoints. Notice that all 3 functions have exactly the SAM logic. The only thing that changes is the API endpoint. Instead of repeating the SAM try-catch block 3 times, let's extract the common code into a helper function. Now, each public function simply tells the repository which API to call, while the helper function handles the network request and error handling. We can use this single function for trending, popular, top-rated, and upcoming movies. This keeps our repository clean, reusable, and easy to maintain. Now let's update our view model to load all the movie categories. We'll keep everything inside view model scope. because these are asynchronous operations that should be cancelled automatically when the view model is cleared. Inside the coroutine, we're using supervisor scope. This is useful when we are making multiple independent API calls, because a failure in one request won't automatically cancel the other requests. Now we need to fetch 4 different movie categories. Instead of making these API calls one after another, we are going to use async. Each async block starts its API request concurrently. This means all 4 requests can run at the same time instead of waiting for the previous request to finish. Once all the requests have been started, we use await to get their results. Now we have the results for all 4 categories. Finally, we'll update our UI state. VSet is loading back to false and update each movie list with its corresponding result. We are also using a safe cast to network result.success. If a request fails or empty, gives us an empty list instead of crashing the UI. Let's connect them to our home screen and run the application to see our current progress. We now have a complete home screen with multiple movie categories. We have trending movies, popular movies, top-rated movies, and upcoming movies. Each category has its own horizontal movie carousel, and we can scroll through the movies independently. At the same time, the entire home screen can be scrolled vertically to browse through all the categories. In the upcoming episodes, we'll start improving the design and adding more features to make our app feel much closer to a real-world OTT platform. We'll work on things like a featured movie section, better movie cards, animations, and the movie details screen. If you enjoyed this episode, make sure to like the video and subscribe to the channel. Thank you for watching.